In the last lesson, we learned about piecewise functions. Today, we're going to continue this by first reviewing piecewise functions as a lead-in to today's lesson, which is about a special type of piecewise function called a step function. For our first example, we have a piecewise function that has three pieces. I'm going to label them 1, 2, and 3 because we need to know which equation we're going to be plugging into for this first exercise. So just for the sake of it, I'm going to call the top one number 1, second one is number 2, and third one is number 3. That way, when I refer to the first equation, it would, of course, be number 1, second equation, number 2, etc. What we're going to do first, which we did not do in the last lesson, is we're going to evaluate this piecewise function at certain values. Now, what's important here is that we need to know, since there's three pieces in this function, we need to know which function we're actually plugging into, and that's going to come into play with the constraints of that function, specifically as they relate to our input. So in this first example, we're trying to find f of negative 4. So we need to ask ourselves a couple of things. Number one, we need to ask ourselves, is negative 4 less than or equal to negative 1? Is negative 4 between negative 1 and 2? Or is negative 4 greater than or equal to 2? In this case, we can say that negative 4 is less than negative 1. So the constraint that this one would apply to would be the first equation. But since I am going to look at the first equation, that means I'm plugging in negative 4 into x squared plus 1. So f of negative 4 is going to equal, and again, when inside is your input, so everywhere I see an x in that first function, I'm going to replace it with negative 4. So it becomes negative 4 squared plus 1. Anything squared is positive. So this becomes positive 16 plus 1, which is 17. So the value of this piecewise function at negative 4 is equal to 17. Now for the second one, we're finding f of 0. So again, we have to ask ourselves, which constraint does 0 fall into? Well, 0 is not less than or equal to negative 1. 0, however, is between negative 1 and 2. So since 0 is between negative 1 and 2, we're going to use the second function to plug in our input. So we're going to take x plus 4 and evaluate it at 0. So again, I'm going to replace 0 where I see an x in the second function, so it becomes 0 plus 4, which equals 4. The value of my piecewise function at 0 is equal to 4. Now lastly, we want to find the value of the function at negative 2. Negative 2 is less than or equal to negative 1. So we're going to end up actually using that first function twice. All right, so we're going to take, again, we're going to take x squared plus 1, and this time we're plugging negative 2 into the x. So function evaluated at negative 2 is going to be negative 2 squared plus 1. Again, I'm using that first function to plug in because that is the constraint that negative 2 fits into. So this becomes positive 4 plus 1, which gives me a value of 5. So the value of this piecewise function at negative 2 is equal to 5. Now let's take a quick second for you guys to try one on your own. So if you're watching this, stop the recording, give yourself a minute or two, and do this example. All right, so now your example has three pieces as well. So again, I'm going to call this one piece number 1, this one is piece number 2, this one is piece number 3. All right, with each of them having their own constraints. One thing I do want to point out is notice that two of them, this one and this one, so pieces 1 and 3 are constants. That is the same as a horizontal line, because essentially what we're saying is that y equals 4. The equation y equals a constant is a horizontal piece. Basically, this is a horizontal line at 4 to the left of negative 2. So I want you to keep that in mind because this is going to be really important once we get to the step function. All right, so your first input that you were looking at was f of 7. If we go back to our constraint, 7 is not less than -2. 7 is not between -2 and 4. 7 is greater than 4. So since 7 is greater than 4, we're going to use equation number 3 to plug in 7 into. Now, what's interesting here is that equation number 3 does not have an x. Piece number 3 is basically saying the value of that function is 6 for any x value that is greater than 4. So since 7 is greater than 4, f of 7 just equals 6. Now for the second one, f of -6, again, we're going to go through the same exercise. Turns out -6 is less than -2. -6 is less than -2. So that means we're going to use the first equation. Oops, let me stick with my notation here, or it'll bother me. We're going to use the first equation. All right, this one also is a constant. This is basically saying for this first piece that the value of my function is 4 for any x that is less than -2. So since -6 is less than -2, we can say that our function is equal to 4. So those ones were kind of easy. Last piece you had to do was find f at -1. -1 is not less than -2, but -1 is between -2 and 4. So -1 is between -2 and 4. So that means we're going to use the second piece to evaluate our function. This time, this is an absolute value function. So remember, absolute value functions basically change everything. Everything is positive that you put in. So if I put in a negative, the absolute value of a negative is positive. If I put in a positive, the absolute value of a positive is a positive. So if I'm evaluating this function at -1, as I'm using that second piece, I'm taking the absolute value of -1. I'm replacing that x that's inside with the -1. Well, the absolute value of any negative number is its positive counterpart. The absolute value of -1 is +1. The value of my function at -1 is equal to 1. Now, just for the sake of it, since this is going to be a good lead into what we do with step functions, let's go ahead and review sketching a piecewise function. All right, so this first one that we're going to look at has 3 pieces. Once again, now I'm going to color code these to make the pieces easier. So I'm going to make the first piece green. I'm going to make the second piece red. And I'm going to make the third piece, let's make it aqua. Sounds good to me. All right, so the green will be the first piece, red will be the second, aqua will be the third. So let's look at that first piece right here. Again, remember, if it's constant, that is a horizontal line. And in this case, the horizontal line is going to be everything to the left of -2. So my endpoint of this horizontal line is -2. Because there is an equal to under the inequality, it will be a closed dot. And because it's less than or equal to, think of where it's pointing left. That means I want the left piece of this horizontal line beginning at -2. So I'm going to go ahead and look at where my point is at -2. So at x equals -2 for that first piece, my y is going to be -4. So here's -2, here's -4. It is a closed dot because of that equal to underneath the inequality. And since I want it to be, I'm looking at the value of the function when x is less than or equal to -2, I want the piece that is to the left of that dot. So I want everything that is to the left. All right. So that was, you know what I just did, guys? I completely used the wrong color. So let me go back. The graph is right. The color's wrong. I said I was going to make that first piece green, but now it's green. All right. So there's our first piece. All right, so now we're going to look at the second piece. And actually, I'm going to start over. Let's take away what I wrote here. I actually had to pause and then come back. And so that's why you see something there that I'm actually going to erase. And I can't figure out how to erase it on the video itself. So let me erase this first, and we're going to go start the second piece all over again. All right, here we go. So for the second piece, it is a line. It has 2 endpoints for its constraints. my leftmost endpoint, this is a compound inequality, I've got a left endpoint and a right endpoint. Left endpoint, it should be the value of the function at x equals -2. It should have a open dot because there's no equal to. The right endpoint should be the value of the function at x equals 2. It should also be open because there is no equal to in that inequality. Now, I want to figure out the endpoints first because then it's just easy to figure out what the line should be between them. So for the second piece, I want to find f of -2. Oops, let me get the pen. I want to find f of -2. Work, pen. There we go. All right, so I'm going to plug in, well, I don't have to plug anything in because as we saw in one of the previous ones, for any value, if it is less than, I'm in the wrong section. Sorry, guys, I'm on the second function. Start over. So for this function, I'm taking x minus 2 and I'm plugging in -2. So f of -2 is going to be -2 minus 2, which is -4. So I should have a closed dot at -2, -4. All right, which happens to be this endpoint right here. Now, since that one is already closed, we're going to just say it's closed here at this point. All right, so that's our left endpoint. Now, to find the right endpoint, I want to find the value of the function at x equals 2. So at f of 2, I'm going to take 2 and subtract 2. So again, I'm taking this function and plugging in 2 right there and then subtracting 2. That gives me 0. So I should have another endpoint. My right endpoint should be at 2, 0. And it should also be open because there is no equal to under that inequality. So now there is my piece of my line that I want. And forgive me, guys, I'm horrible at drawing lines, straight lines. All right, so there is my piece for number 2 that is between x equals -2 and x equals 2. All right, now third piece, also a line. This one has a y-intercept of 4 and a slope of -2. And I want the piece of this line that is to the right of 2 because I want my constraint is that x must be greater than or equal to 2. So what I'm going to do for this one is I'm going to first figure out where since my starting point is going to be at x equals 2 for this piece, I'm going to figure out what the value of my function is at 2. And then I know I want the line is going to be, the line I want to see is everything to the right of that because that inequality is pointing to the right. It's greater than or equal to. So for the third piece, let me get my colors right. So for the magenta piece, I want to find f of 2 using this equation because now this is the piece that I'm on. So I'm going to take -2, multiply it by 2, and then add 4. That's going to be -4 plus 4, which is 0. So I should have my endpoint, my starting point for that piece should be at 2, 0. I plugged in 2, got out 0. Well, that happens to be this endpoint of this piece. So we're going to, and it is closed. So we're going to just go ahead and make this endpoint closed for both of them since they share that point and one of those is equal to. Now, I want the piece of this line that is to the right of this value. Well, remember the slope is -2. So from this point, I'm going to go down 2 and over 1. So there's my next point, down 2 over 1. There's my next, down 2. You can keep going forever, but that's enough to draw the line. And I want everything that is to the right of that point. I'm going to put an arrow right there. So there is our piecewise function with its 3 pieces. Now, you guys stop the video, take a bit to do you try number 2. All right, guys, this one was a little bit more challenging because you do have a quadratic here. You do have to remember how to graph a parabola. But just for the sake of being consistent, again, I'm going to do the first piece. I'm going to call it 1. It'll be in green. Second piece is number 2 in red. Third piece is number 3 in, well, whatever you want to call that. All right, so let's work on the hardest piece, which is piece number 1. This is a quadratic. It is squared. We know by now that a quadratic is that U-shaped parabola. Now, hopefully you remember, and I'll just make a quick note here, that for number 1, parabolas have a vertex. This vertex right here is at 0, -1, because it wasn't shifted right or left, but it did get moved down 1. So the vertex of this parabola is at 0, -1. Now let's say you didn't remember about the vertex. If my constraint is x is less than or equal to 0, I would need to figure out what is the value of this function, this piece, at 0, and then I want to show the piece of the graph that's to the left of that. But at the very minimum, I need to know what that value of that function is. So what you could have also done, if you didn't remember about the vertex, you could have taken that function x squared minus 1 and evaluated it for 0. So if I plug that in, I'm going to get 0 squared minus 1, which is just 0 minus 1, which is -1. So again, you still get 0, -1. So at this boundary right here, I should have a closed dot at 0, -1. Okay. Now, because it is less than or equal to, and it's pointing to the left, I want the piece of this parabola that is to the left of 0. So what I'm going to do to get a decent shape is I'm going to plug in a couple of points. You could also do this in Desmos, but I'm going to be honest, I'm not really good at popping back and forth between screens on videos. So I'm going to show you how to do it algebraically. If you want to graph the piece and use the table of values to find these values, that's completely fine as well. But I'm going to find a couple of more points. So I'm going to find f of -1, because that's a piece of one that's to the left of that boundary. If I plug in -1 to x squared minus 1, I get -1 squared minus 1. That's going to be 1 minus 1, which is 0. So I have another point at -1, 0. And then if I plug in -2, I'm going to take -2 squared minus 1. That's going to give me 4 minus 1, which is 3. So at -2, I'm at 3. Now at this point, so this is enough for you to visually see what that U shape is going to look like to the left of 0. So now I can just sort of go ahead and sketch in my curve. So that you can sort of see it would have been a U if I kept going to get the other piece. But there's a piece of that parabola that is to the left of 0. The second piece is a line, has a y-intercept of -1 and a slope of 2. But again, this is a compound inequality. So you're showing a piece that is between two different values. So just like I did in the other example, I'm going to evaluate the function at 0. That's going to be my left endpoint. I'm going to evaluate the function at 5. That's going to be my right endpoint. And then I want the piece that is between these two values. All right, so for number 2, I want to find f of 0 first. And again, I'm plugging into this equation. So it's going to be 2 times 0 minus 1. That's going to be 0 minus 1, which is -1. All right, so my left endpoint, which should be open because there's no equal to, I should have a point at 0, -1, which is right here. Now that one was already closed for the other piece because there was an equal to there. So we're going to just leave it closed for both of them. All right, so there's 0, -1. That's my leftmost endpoint for that one. Now I'm going to find my right endpoint, which is when x is 5. So I'm going to find f of 5 in the same function. So I'm going to do 2 times 5 minus 1. That's 10 minus 1, which is 9. All right. So now I realize this only goes up to 8, so we're going to make another piece right there. Or increment right there. We're going to call that 9. So my other endpoint is at 5, 9. I'm going to go over to 5 and up to 9. Now that one should be closed because there's an equal to. Now I could try to draw this straight line, but it would be really horrible. So I'm just going to use the slope of 2 to connect them. If y'all are good with straight lines, be my guest. So up 2 over, sorry. Go away. I don't know how to make it go away. All right. I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. All right. So there is that's my entire piece between this endpoint and this endpoint. All right, that's piece number 2. Piece number 3, remember if it's a constant, it is a horizontal line. So I have a horizontal line that would cross the y-axis at 3, but I want it from x is greater than 5. So here is 5. At 5, the value is going to be 3. And at any value greater than 5 is also going to be 3. So here is 5 on the x-axis. Here is 3. That should be an open circle. Ooh, what was that? Let's start that over. This should be an open circle. And I want, because it's pointing to the right, I want this horizontal piece, all of it that's to the right of that open circle. And there you have it, guys. There is your 3-piece piecewise function for the second U try. All right, now we're going to extend what we just did with the second example. So we graphed a piecewise function. I did one, then you did one. Now we're going to extend it, and we're going to look at this concept of average rate of change. I am going to call this ARC, so I don't have to write this. So average rate of change is the same thing as the slope. Well, if you're talking about linear pieces, it's the same thing as the slope of that piece on whichever piece you're looking at. So in this case, I want to go back. It says go back to example 2. So we're going to go back to this graph right here, and we're going to look and find the slope of that function, that piece, when x is 3 all the way to x is 5. So basically, I want to look at the interval from 3 to 5 and figure out, first of all, which piece am I on, and what is the slope of that piece. So if I go back to this graph right here, again, I want it between 3 and 5. So let me get a different color here. Here is 3. Here is 5. And I want the slope between those points. Well, that puts me on piece number 3. That is a line, so it has the same slope on any portion of that line. So all I have to do is figure out the slope of this piece, but I already know it. Piece 3 has a slope of -2. So again, since my interval from 3 to 5 puts me at piece number 3, the slope of that piece is -2. Therefore, the average rate of change from 3 to 5 is -2. Ooh, that is not what I wanted. I'm doing really horrible with my color. So let's use green, because that's easier to read. All right. There we go. All right, now you guys, this should go pretty fast. Do the same thing. This time you're going to use example 3. So this time you're going to use this graph, the U try 2 that you just did, do this example. All right, so again, you're going back to your U try here, and you want U try number 2, and you want to figure out the average rate of change between x is 1 and x is 3. So if I do the same thing, x is 1 is right here, 3 is right here. Any of those values puts me at this piece. Well, that piece is piece number 2. It's the red piece, right? That line, if you look at its equation, that line has a slope of +2. So since my interval puts me on that piece, I'm going to use its slope to identify the average rate of change. So the slope of that piece is 2. Therefore, that you should have been able to say that your average rate of change is 2 for that U try that you did previously. All right, guys, so now let's look at the meat of what we want to discuss today. We just reviewed piecewise functions. We threw in there evaluating a piecewise function as well as the new concept of average rate of change. Now we're going to look at a step function. A step function is a special type of piecewise function. All right, and it's special in that all of its pieces are horizontal or constant pieces. So basically, all of the pieces are a number, because remember, horizontal lines are y equals some value, and that value is wherever that piece would cross the y-axis. So if you look at this first example, you've got 3 pieces. So this is still a three-piece piecewise function. However, what you're going to notice when we graph these segments is it's sort of going to look like steps, hence step function. So this first piece right here, and I'll go ahead and I'll continue color coding. So we'll do first is 1, second is red, third is aqua. All right, if I'm looking at this first piece right here, it is a horizontal line that would cross at -3, but I only want the piece of that line that is left of -2. All right, because it's pointing to the left, less than, pointing to the left. All right, so if I go to -2, at -2, that value should be -3, and it should be an open circle because there's no equal to there. Now, since it's pointing left, I want the piece of the function at, I want everything that's to the left of -2. That is going to go there. All right, so you could make it longer, but I want all of that horizontal line that is to the left of -2. So it would continue on. Now my second piece, all right, now our second piece is a horizontal line that would cross at y equals 0. But this piece is going to start, have a left endpoint of x equals -2, whatever the y value is, and have a right endpoint of 1. So I want to look at this horizontal line, crosses at 0, and I only want to look at it between -2 and 1. So for the second piecewise function, again, we're going to do left endpoint first. At -2, here's -2, my y is 0. It should be closed because there's an equal to there. And also notice if it's on the same vertical line, if it lines up, one has to be open, one has to be closed. You cannot have two closed points on the same x value. It wouldn't be a function then. So then our right endpoint at 1 also has a value of 0. So at 1, which is here, also has a value of 0. It is also closed because both of those are equal to. And there is my horizontal piece between those two values. All right, and then the final step is a horizontal line that crosses at 3, but I only want to see that piece from 1 to the right because I want x is greater than 1 pointing to the right, so I want the right side of this horizontal line. So at 1, my value should be 3. It should be open because there's no equal to. Because it's greater than pointing to the right, I want the piece that is to the right of that endpoint. Now, if you look at our final graph, I mean, just take a look at it. It sort of looks like stairs. If we were to do some little dotted line things right here, it would look like stairs. And so we call it a step function. All right, guys, take a second and you try number 4. All right, I'm going to make that first step green. Second step will be red. And third step will be aqua. All right, first step is a horizontal line from 0 to 3. So at 0, the value should be 2. So 0, 2, that should be a closed circle because that's equal to. At 3, the value is also 2. So over 3 up 2. That should be an open circle because there's no equal to there. And then I'm looking for that piece that is between those 2 points. So that's my first step. Second step, I want this horizontal line between the values of x equals 3 and 5. So at 3, the value is 5, so over 3 up 5. It should be closed there, again, because there's an equal to right there. At 5 should be an open circle, also at 5. So I'm going to go 5, 5. Also, oops, let me fix that. It should be open. All right, I should have an open circle at 5, 5. And I want everything in between it. All right, and the last piece is -4. So this is a horizontal line crossing at -4, but I only want to see the horizontal line between 5 and 10. So at 5, my value is -4. So I'm going to go over 5 down to -4. It should be closed because this one's closed. Also, that if that one's open, well, it could be both open, but it's closed because that's an equal to. At 10, it is also -4. It should also be closed because there's an equal to there. Now I'm going to go over to 10. and it also should be -4. So there's the piece of that horizontal line between those two values. So hopefully that is what you got for your piecewise step function. Now the last thing we're going to do is now we're going to go in reverse. We're given the graph of the step function. We want to write it as a piecewise function. Now, your piecewise function will have as many equations as there are pieces. So for this first example, I have one piece here, another piece here, and another piece here. I have 3 pieces. So that means my piecewise function should have 3 equations. All right, so let me move this down just a little bit so we can see. We're going to call this piece number 1. We'll call this piece number 2, and this piece number 3. I'm not going to label them, but at least I can color code them so you can see which equation goes with which of those steps. So we know by now that all piecewise functions start with f of x or g of x or h of x. We'll just say f of x equals single brace. And now inside the brace is going to be the number of equations that represent the pieces in the function. This one has 3 pieces, so we should have 3 equations. Now all of these for any step function are horizontal. So that means all of my equations should be a constant number. This horizontal piece, this first piece, if I go left to right, would cross at 1 if I extended it. So its value is 1, and its constraint, the endpoint on the left is x equals 1. The endpoint on the right is x equals 2. Just make sure your inequalities are correct. This one is a closed dot, so its inequality should have an equal to. This one is open, so it should not. So my constraint for this one is that my x's must be between x equals 1 and x equals 2. Because there's a closed dot there, I'm going to make sure I have a equal to under that inequality. And then because this one's open, I'm not going to have an equal to, and its value is 2. So once again, I'm going from 1 to 2, x equals 1 to 2, and the value in between those points is 1. Okay. Second piece is a horizontal line that would cross at 2. So its value is 2 between, this is 2 and this is 3. So its value for the second step is 2 between x equals 2 and x equals 3. I should have the first inequality should be an equal to, because there's a closed dot on that left endpoint is closed. And then I should have an open inequality for the right endpoint. The right endpoint is at 3. So again, between 2 and 3, the value of my function, my second step, is 2. Last step, number 3, that's a horizontal line that would cross at 3, and I want it between x equals 3 and x equals 4. So its value is 3, and I'm looking at that piece that is between 3 and 4. And again, make sure your inequality symbols are correct. This one has an equal to underneath it because that left side is closed. This one does not have an equal to because that side, the rightmost endpoint is open. Now you guys take a second to do that last few tries. All right, again, step number 1, step number 2, step number 3, and then now we've got a 4th step, so I got to use the 4 colors. So there's step number 4. All right, starting leftmost, again, we know it's going to start with f of x equals open brace, and then we should have 4 constants because I've got 4 steps. So first constant, that value, that is a y value of -1. It would cross at -1. And it is between the values of x equals -6 and x equals -3. My left endpoint should be an inequality less than or equal to, let me start over. The left inequality should not have an equal to because it's open. The right side endpoint should be an equal to because it is closed. So again, this piece is between -6 and -3. We can say it like this. All right, now again, this does not have an equal to because that is an open circle. This right here does have an equal to under it because that is closed. My second step has a y value of 0. And its step is between -3 and x equals 0. For the same reasons, those inequalities are as they are based on the dots. Third step is that's a horizontal line that is crossing at 1. Oops, where's my color? All right, that step is between x equals 0 and x equals 3. And then the last step, it is a horizontal segment or horizontal line at -2, but it's between x equals 3 and x equals 6. Sorry, not -2, +2. The y value is +2 between 3 and